Okay. So, good afternoon. Today we will be talking about the class diagram, right? So, if I move on, we will be go through with a brief introduction, and we will discuss what are the elements of the class diagram, and uh, and different method how we represent the relationship and those kind of things we will be discussed, right? So whenever you are developing the class diagram, so you have to develop your use case diagram before starting to draw the class diagram, right? So in the class diagram, the double OP concepts will be utilized. Anyway, the entire UML is for object-oriented analysis and design. So in that case, double O concepts will utilize, right? So for example, inheritance, encapsulation, etc. So then in the class diagram, as its name, it will represent the structure of a system based on the classes, right? So in object-oriented concept, we have classes and objects. So the class will be act as a blueprint, and objects will be the whatever instance of that particular class. For example, the most common example is cookie cutter and the cookies, right? So let's assume we have a star-shaped cookie cutter, right? So when we use that particular cookie cutter, star-shaped cookie cutter, any of cookies will have star shape, right? So this is that classes and objects. And also, there are relationships among these classes. Some classes are acting as a superior level classes. Other one will be act as minor levels like parent-child relationship, right? So those kind of different relationships there will be, right? So this class diagram, right, we can use in the analysis part, right? So usually it will illustrate common roles, responsibilities of different entities or the classes. And during the design, by developing this class diagram, you can basically illustrate or the display the structure of the classes of the system. Okay, so this is the recap of the object and classes, right? So you can go through. Yeah. So when it comes to the object, right? So the object will have a unique identity, unique name. Each and every object will have a unique name. And that particular objects will have different states, right? So in the object-oriented world, these states can be either static or dynamic, right? So the static will be not changing values, right? Some sort of like properties, etc. And also the objects will have current values. So those current values can be variated within the time frame, right? Due to various calculations etc. So in that case, these states will be dynamic, and also objects will have different behaviors, right? So how we going to create objects? So we simply use class as the template of creating objects. So you have to remember the learnings that you have learned from the either Java or Python or any other double O programming language. So in C++ also, okay. And when it comes to the elements of class diagram, so we have two different main elements, classes and the relationships, right? So this is a very easy diagram, right? So you basically you have to you are allowed to represent only classes and the relationship between the classes, right? So we don't need to think whether that particular class is executing its operation in parallelly. Do we take what we call different decisions? So we are not going to worry about those things. We just simply try to illustrate the system's classes and the relationship between the classes, right? So if it this will be the notation, right? So in a class, so at the heading you have to give the class name. And then, when you are initiating the class using any programming language, so you might have different attributes, right? So you have to give what are the attributes and its type, right? And then you have different methods or the operations or the functions that can perform from that particular class, right? So in that case, you have to give the operations name and the return type, right? So for example, this would be a simple example. So in here, so you can see this is object, right? So in this this object, right? So this is object type is string, and the name is calibration temperature, right? So when it goes to this operations, right? So you can see this is the operation name, and this is some sort of what we call parameter that is passing to this particular function, and this would be the parameters type, and this is the return type. Since the return type, this particular method is not returning any value, right? So we can state as void. So in the Java, if you are using the public static void main, so in that case, the void is indicating that there is no any return types, right? And so, so let's assume, so you have a something, you have a class, and then you have, let's assume, patient age is your age calculation is your method, and there you simply getting age as the parameter, and so I'm writing the Java code here, right? So let's assume age is equal to age plus let's assume 10, right? And then you simply return a, right? So in that case, since you are returning some sort of value, right? So let's assume this is a integer value, right? So you are basically passing integer value to here. And so in that case, you have to indicate this, this return type in somewhere like it. So in that case, instead of void, you have to write it, right? So then in the class notation, right? So whenever you are try to develop the class diagram and you are drawing the classes, right? So in the name, right? We need name for each and every class, right? So this name, class name should be unique. So in usually programming languages like Python, Java using class names in the camel case, right? So in that case, you have to follow something like this. So this is camel case. So simple, and each and every new letter word should be in the capitals, right? And when we talk about the attributes, right? So I have shown in here is a very basic example, right? But actually, if you are really concerned illustrating in depth of about your attributes of your class, right? So in that case, this is our format, right? So you are first thing is you have to indicate what is the visibility, and then you have to do the write the attribute name, then type multiplicity, and you have to give some sort of default value and property string. So these are from actually Java, right? Java and Python, we have that, right? So these are the some examples. So you can see we have plus and minus here. So these will be the visibility. I will explain later what are these plus and minus, right? So then you have the attribute name here, right? Then you have the what is the type of your attribute, right? So then this is ended in here, right? So this will be multiplicity. It means this measured temperature, right, can go 0 to 60. So something like in the ER we are telling 1 to M, M to M, something like this, right? In here, instead of telling 1 to M, right, we simply give values, what is the starting point and ending point. So in here, 0 to 60 will be the set of values, value range, right? So this is this multiplicity, and this will be a property string. So then you have the operation, right? So the operation will be either in C++ it is function, in Java it is method, in the Python also it is function, right? So the operations is basically either this is Java, this is no, this is Python, right? So again, you can see something similar to this general format, right? So you have visibility operation, sorry, visibility operation name, parameter name and type, return type and property string, right? So you can see again visibility, operation name. So these are the parameters and the type, parameter and the type. So you can then return type. So in this particular login, right? So it is return type is Boolean. So Boolean means either true or false, right? In some cases, you can have returning a list. Some cases it can be a array, right? So I think like if you are utilizing different machine learning related things, so arrays will be the most common return types, right? So then we have integer, float, string, those kind of things, right? So make sure operation should contain visibility, method name, arguments. So in the parameter name and parameter type you have to do, return type and property string should be there, right? So reason of giving those values, right, in class diagram, right? So later you will be learning, right? There is a concept called what we have two concepts actually: forward engineering and reverse engineering, right? So there is a tools, right? So for example, IBM Rational Rows, Star UML, etc. So when you have created the class diagram using tools, right? Like Star UML, etc. Basically, you can generate the code classes, right? So if you add these visibilities, attribute types, parameters, parameter types, return types, right? Each and every will generate for you. So that is a very easy way. So that's why actually we have to uh, give all the values. Although you are not doing this forward engineering or the reverse engineering, right? So if you give these all information, right, developer can actually understand. So that these are you have to use in my Python, sorry, the code whenever I implement, right? So in the visibility, right? So we have, so the visibility is basically when we have like different visibility levels, it will tell who can see what sorry yeah what elements can see in one class by other class, right? So we have public. So if your code start from something like public static something, so your visibility is public, right? So the public is so the word public you can understand, right? So any element can see the uh, so that we have that this class, right? So we have element 1, element 2, and if this is a public, right, class, so we have other class, they can visualize, right? Not only the class but also inside elements. So when it goes to protected, right? So protected is hash, right? Um, so in some cases you have a class, right? This is let's say protected, and have subclasses, right? So in that case, and also we have other classes, right? These are just connected, not we call subclasses, right? These classes actually can't see, but so the protected means it is protected from the public view, but it is visible within the class and to other subclasses, right? So when some cases you can have variables or the classes, right? Private, something like this, right? So in this case, so you have the class, this is basically fiber, and we have other classes which is having some sort of relationship, right? Since it is private, whatever inside the class is can be, but rest of other things, even in the subclasses, can't see. It is protected, right? So then we have this package. So usually something like I think this is should be the code. Sorry, package. Let's say Y, and then we have our class name, right? So in this case, this is belongs to a package. So in that case, right, whatever available within the package, classes within that package, the same package can be the inside of the class, right? So you can see. So this is public public protected fiber package, public private, right? So see that when you illustrate your class diagram with each and every aspect, right? Actually, right, you can write your code, right? So in this case, this is something. Actually, in the Java, we are not in Java, we are not using public keyword. Whatever we use, right? And, it will be something. So we have string, user name, something like this, right? Then in this is protected. So in that case, so private PW, so string it, right? So something like this. So you can basically generate. Then you have the class relationship, right? So as previously I mentioned, so in the programming world, we have different relationships, right? So if we talk about this simple example, right? So the entities is actually present in the class, right? So let's say we have flowers, daisies, red roses, and yellow roses, right? So if we talk about the relationship among these four, right? So we know Daisies are type of flowers. And then we have red and yellow roses. Again, roses are another kind of flower. Right? This red rose and yellow rose, these are same kind of roses. Right? So in that case, we have flower, daisies, then roses, right? And then right? So this is a very simple relationship. So the basically this relationship when it comes to the class, right? So these class relationships will tell you how the classes are connecting or the collaborating each other, right? So we have four different cases: association, generalization, aggregation, and composition, right? So when it comes to the generalization, right? So you can see the word generalization, right? So it is basically dealing with subclass and superclass case or the parent and child relationship, right? So in here you can see we have parent class and the child class, right? So this is the symbol. This is how we tell outside people these classes having generalization or the what we call subclass superclass relationship, right? So you can see so we have flowers, daisies, roses, right? So right? So we know that roses are the parent one and the red and yellow are the special cases of rose, right? So in that case, if you are reading bottom to up, it means from red roses, yellow roses, it is roses. It belongs to whatever rose family, right? So this is generalization. So if you are moving down, it means you are basically having a general case called flowers and you are dividing into different cases like daisies, roses. In some cases, we can have lotus, right? Something like that. So that this would be specialization as it is going from general case to special cases. It is specialization, right? So this is the another example, right? So in the we know a book item is an item of the library. Library එකේ තියෙන කොටසක් iPod item එකක් තමයි book එකක් කියන්නේ. Right? So this would be the parent class and this is our child. Right? This is generalization. So then we have dependencies, right? So This dependencies actually illustrate you the what are the dependent element, and it will also tell how the direction the dependency direction is happening, right? So we use a dotted arrow, right? So usually the arrowhead represent the independent one. End of the for the tail of the arrow will illustrate the dependent element, right? So in when it comes to something like in the what we call so when you have this weak entity case, right? So in that case, you have the employee and it's connected with child, right? So whenever this employee is no longer there, so the child is, we don't want to make it. So these kind of dependent independent cases, when we have within our code, we can actually represent using this notation. Then we have the association. So the association is a normal case of the relationship, right? So it basically connect two classes, right? Something like this. So you have class 1, you have class 2. It's something like this, right? So for a given class, there can be more than one association between the same pair of classes, right? So this can be something like let's assume this is belongs to create, and this is something file, right? So this can be happen, right? When you have association, so for a one class, so for a same pair of class, there can have more than one association. And also, like we are telling the multiplicity in the ER, right? We can also tell the multiplicity, right? So as the databases, so we have one to many, many to many, right? So in here, this is the example, right? So if you have the vehicle, right? And so let's see car, right? So we have like different, sorry, not car too. So we have wheels. So so if we take the vehicle car, right? So we know car has 4 wheels. So in that case, so one car have 4 wheels. This is the way we are reading, right? But each wheel, we are having only one vehicle. එකම wheel එක වාහන දෙකක නෑනේ. එක wheel එකකට එක වාහනේ තියෙන්නේ. So this is how one to many is happening. So the many to many is other way around, right? So we have student and teacher relationship classes, and it's a fact, it's meant to make, right? So this is the notation for the association, right? It is indicating basically normal relationship, right? Rather than this generalization, etc. So you have class 1, class 2, and you have to give a label for each and every association, and you have to give the multiplicity also, right? So this is something like that, right? So instead of writing M, we can put even star here. And then we have the aggregation, right? So the aggregation, so indicating part of relation, right? So in some cases, like if we get vehicle has something like wheels, even though vehicle is not longer there, wheel can exist, right? වාහනේ ටයර් එක ගැලෙව්වා කියලා ටයර් එක නැති වෙන්නේ නැහැ. ටයර් එකට stand alone ඉන්න පුළුවන්. So this is the part of relationship. So it means this is sort of independent, right? So how we tell this part of relationship? We simply use this notation, right? So the starting or the end of your arrow, right? The straight line, the class that connected with the straight line would be the part. The diamond shaped arrowhead will be connected to the aggregate class or the bigger. So in this case, this would be vehicle and this is V. Right? So in the library, you can see, although library is not available, book item, newspapers, CDs can be there. Right? So this is aggregation. So then we have this composition. So the composition is other way around of the aggregation. So it means something like we have the employee, we have the employee's children information. When the employee is no longer in the company, child also delete. So these kind of weak entity related relationship type is available in the class diagram as the composition, right? So we can simply, so you can remember in the aggregation, this is just a diamond, empty diamond, but in the composition we have to color it. So in here we have the composite and this is the part. So this would be the child, this would be the employee, right? So in the library, right? So library, we have a component called catalog. So the catalog, right? So when the library is no longer there, catalog is meaningless. So then catalog should be cannot be a individual item without the library. So in this case, This library is the composite one. Catalog is the part class. You simply use this notation. So so if we like go through again, right? So we have association, aggregation, and composition. So the association is the normal case, right? If the if there is a strong relationship, we use composition. Strong association, we use composition. If there is this part of association, we use aggregation, right? So these are the summary of this association, aggregation, and composition, right? So these are the examples. This is general association. This is generalization, composition, and the aggregation, right? So then we have the variables and methods. So in the variables and methods, we have different variables that is used in the program, right? So we can simply illustrate those things also, right? So we can have static variables and methods, right? For example, this is how we write it, this static variables, right? And methods in the using Java, right? So this is the visibility. So this is the static keyword. So if you have static keyword, so it means static variable or static method, right? Something like that. So whenever you are denoting whatever static variable or method, so you can see after you are writing your notation, you have to underline in order to indicate this is static, right? You can see it, right? So then when it goes to this final variable, so the final variable means actually this is not a variable, this is a constant. So in that case, these final variables, we have to use all capitals. So this particular final variable is normal final variable, right? But in here, you can see it's underlined. It means, right? It is final and static variable, right? Then if you have normal methods that is not belongs to the static methods, you simply write the name, right? Okay, that's about class diagram. So do you have any concerns or questions?